Hello friends, this is Professor Himanshu Deshmukh. Today we will see second problem on projectile motion. So let's begin. Our today's problem says that a bullet is fired with a velocity of 30 meter per second from a point 15 meter in front of a vertical wall, 8 meter in height. Find minimum angle of projection to the horizontal to enable the bullet to just clear the top of the wall. Okay. So again, before proceeding, I request you to kindly pause the video and go through this particular numerical once again so that you get what is being given in the numerical and what is asked in the numerical. Okay, you should be able to draw a initial figure, okay, from the question which is given. Okay, so now let's draw the figure. Now in this particular problem, it is said that there is one bullet. Okay, so this is bullet. This bullet is fired with a velocity of 30 meter per second. Okay, it is fired with a velocity of 30 meter per second. So a bullet is coming with a velocity of 30 meter per second from a point. Now this is the point from where the bullet is fired, which is 15 meter in front of a vertical wall. Okay, so there is a vertical wall and this point from where the bullet is fired, it is at a distance of 15 meter in front of wall. Okay, so this point is 15 meter in front of wall, 8 meter in height, and the height of wall is 8 meter. Okay, so this is the given condition of our problem. Now in this particular problem, you have to find minimum angle of projection so that the horizontal with the horizontal to enable the bullet to just clear. Okay, so now you have to find out the angle with which this bullet is fired so that it does not hit the wall. It travels so that it just clears the top of the wall. Okay, it does not hit the wall, it should clear the top of the wall. So by what angle? Okay, so suppose this is the angle alpha. So by what angle this bullet should be fired so that it clears this wall, it does not hit that wall. So you have to find out the value of alpha. Okay, so now in this particular case we have been given the value of u, that is velocity, it is 30 meter per second. Okay, so u is 30 meter per second. X is what? X is the horizontal distance. Okay, so this is the horizontal distance that the bullet is traveling. It is 15 meters. So X is 15 meter. What is the vertical distance that that bullet should be able to cover? Okay, it should cover this wall. Okay, it should clear the wall. So the distance of or the height of this wall is 8 meters. So this bullet should clear a vertical distance of 8 meter. So this Y becomes 8 meter. And you have to find out the value of alpha. So this is given condition. Now while solving this particular problem, we already know the basic equation of projectile. The equation of projectile, which is very important, it is given by y is equal to x tan alpha minus g by 2 in bracket x upon u cos alpha whole square. Okay, so now in this particular formula you have substituted all these values. Okay, what you will get? Y is 8 is equal to x is 15, tan alpha is unknown, so it will be alpha, minus g is 9.8 upon 2. Now in bracket x is 15 upon u is 30 cos alpha. Okay, so you have substituted all the values here. Now from this equation, please see carefully how it is solved. Okay, because it is very important. It might look easy, but it is slightly difficult or slightly complicated to solve from this particular step. Okay, so now see. This will become 15 tan alpha minus 9.8 upon 2 becomes 4.9 into, now we have opened this bracket. Okay, so it will become 15 whole square upon 30 square upon cos alpha square, that is cos square alpha. Okay, so instead of this entire bracket square, we have removed each part out of this bracket. Okay, so it is 15 square upon 30 square upon cos square alpha. Okay, now again solving further, it becomes 15 tan alpha same minus now 4.9 into 15 square divided by 30 square. Okay, these three things if we solve, the value comes out to be 1.225. Okay, you can do it in calci. It comes out to be 1.225 and 1 upon cos square alpha. What is 1 upon cos square alpha? It is sec square alpha. Okay, so we have substituted 1 upon cos square alpha is equal to sec square alpha. Okay, now 15 tan alpha minus 1.225 into, now what is sec square alpha? It is 1 plus tan square alpha. So these are the basic trigonometrical formulas. So sec square alpha is equal to 1 plus tan square alpha. Okay, so it is sec square alpha, we have taken it 1 plus tan square alpha. Now see why we are doing this changes, because there is tan involved, and we require all the equation or the entire equation in tan itself. So that is why we are changing all this, or we are using these trigonometrical functions. Okay, so it is 1 plus tan square alpha. Now again solving further, the left hand side is 8. Okay, the left hand side remains as it is. It is 8 is equal to 15 tan alpha minus, now we will open this bracket. So it will become 1.225 into 1 minus 1.225 again minus 1.225 into tan square alpha. So basically we have opened this bracket. Okay, so it is tan square alpha. Now again what we are doing, we are transferring all this left hand side data towards right hand side. Okay, and it will be equal to 0. So this minus term, when it comes to left hand side, it will become plus. So it will become 1.225 tan square alpha. Okay, this minus term again it will go towards left, it will become plus 1.225. Okay, this is plus, so it will go left hand side, it will become minus 15 tan alpha, and 8 is already on left side, so it will become plus 8 is equal to 0. So basically we have shifted all these right hand side terms towards left hand side. Okay, now again if we simplify this particular equation, it becomes 1.225 tan square alpha. We have taken this term here, minus 15 tan alpha plus 1.225 and plus 8 becomes 9.225 is equal to 0. Okay, now if we see, this is a quadratic equation. Okay, it is a square term, this is a quadratic equation. Okay, now if we solve the above quadratic equation, we get, now see in this particular equation, this is a quadratic equation in which the value of x is tan alpha. Okay, so tan alpha is x, so this is nothing but ax square. See, what is quadratic equation? Ax square plus bx plus c. Okay, so ax square, x in this case it is tan square alpha, so the value of x is tan alpha. So if we solve this quadratic equation, you will get two values, but two values will be of what? It will not be of alpha, it will be of tan alpha. Okay, hope you have cleared this thing. So whenever you solve this quadratic equation, you will get two values. First will be tan alpha is equal to 11.59 and tan alpha is equal to 0.65. So now from both these cases, if we find out the value of alpha, now in this case what will be alpha? Alpha will be tan inverse of 11.59. So that comes out to be 85.07 degree. And in this case also alpha will be tan inverse of 0.65. It comes out to be 33.02 degree. Okay. Now we get, see we have obtained two values of alpha. Now what is alpha? Alpha was the angle by which our bullet was fired so that it should clear our wall. So that was alpha. Now in this question it is clearly asked to find minimum angle of projection. So the minimum angle of projection will be the minimum value of either of this. So the minimum value is 33.02 degree. So the minimum angle of projection is 33.02 degree. Thank you.